Welcome to this presentation on unit testing best practices. This video is in continuation to a few other videos that I've already posted on YouTube, such as Unit Testing Rebooted and Test Spies and Test Mediators, as well as Test Doubles. So the first thing is you want to test the interface and not implementation. It seems very obvious or simple. It's similar to the idea of programming to interface and not implementation. When we write tests, we shouldn't be looking at the implementation to decide what we need to test or what kinds of test methods we need to test. So in the past, what I've done is as an exercise for myself, but later on for my teams, I have given them an assembly that's compiled so they can't see the code, and along with this assembly I give them a functional requirements of the class or classes that they might find in this assembly, and they're asked to write unit tests for this. And once they've written the unit tests based on the functional requirements and they have to come up with the scenarios, we then look at the code coverage, if you will, to see if any scenarios were missed. I think this is a great exercise to get people into the groove of writing to the functional requirements and scenarios rather than two classes and the implementation of these classes. Delta coverage should be as close to 0 as possible. This is the delta coverage across the different kinds of tests. So if you remember from the very first part on Unit Testing Rebooted, we talked about acceptance tests and then class tests or class integration tests. The idea is not to write tests for every class, and so the idea is to have tests such that they don't overlap. Now, if you are intentionally making the choice to write a test for a class that overlaps the class, that's one thing. But the aim is not to go about writing a bunch of tests that cover the same class across different kinds of tests, such as acceptance tests and class integration tests and composite tests and so on. It's a very easy mistake to make, but that's not what we want to be doing. So let me show you in diagram form what that might look like. So let's say you have a class and you have your acceptance tests on this class that are covering this class to a certain extent. And then you decide to write class integration tests for the same class. Now, if you make that by choice, if you make that decision by choice, then you know you're duplicating the coverage, as in this the same scenario, and so you're repeating tests at a different level. By level I mean acceptance tests versus class tests or class integration tests being different levels. It's similar to if you were to look at this as a set-based operation, then if that is the set of integration tests and this is your set of class integration tests, then this intersection is what you have to be worried about. Now, in some cases, these are choices you're making intentionally, so that's fine. That's a risk you're willing to take. So the benefits outweigh the cons, if you will. But if you're doing this without knowing, then that's where the problem is. That's where the problem starts to arise, because you could be writing a bunch of tests or huge numbers of tests that are essentially just duplicating the work that other tests are already doing. And is that something you really want? So you have to be very careful of that intersection. As long as you're doing that by choice or by intent, that's of course your choice and your intent, and so you know that you're doing that. But in a lot of cases, because you're doing this unit testing style, which is every class in isolation, you don't realize sometimes that you've got a bunch of tests that are being repeated across different levels of testing. So that's what I meant by delta coverage. Next up is the unit tests should run in isolation from other unit tests. And this is very important. You don't want unit tests that depend on other unit tests, either by way of the fact that maybe one test needs to run before the other or can't run until certain other tests are run. etc. That causes a lot of flaky tests, and so you want to make sure that they're running in isolation. In Ken Beck's book, when he talked about unit testing or isolation, when he used the word isolation, he really meant that the unit tests themselves should be running in isolation. This was because earlier on in his career he was burnt by this fact that when he would come to the office in the morning and he'd see a stack of paper that indicated a bunch of tests had failed, and on examining that over the days, he realized that even though, let's say, 100 tests had failed, it wasn't that 100 tests had failed. It was one test that caused the other tests to fail. And this sort of thing was going on repeatedly, and so he decided to clean up his act and come up with this idea that tests need to run in isolation. Today, of course, when people talk about isolation, they mean that every class should be tested in isolation, but that's not what Ken Beck was talking about. Unit tests should be automated, repeatable, consistent, and minimal. Of course, automated, repeatable, and consistent really means that every time you run the test, they should be automated. They should be consistent in their outcome. In other words, they shouldn't be flaky. And flaky tests actually is a big problem. If as soon as you find you have a flaky test, you need to nail it down. If you let it go on and hope somebody else is going to fix it, it just comes to a point where then people don't run the test because they don't know when to trust a test and when not to. So you need to have tests that are automated such that you click a button and they run. Martin Fowler even talks about this in one of the big reasons he says people should be doing unit testing is for the fact that you can have a suite of automated tests. If you can't automate them through a command line or some other interface, it doesn't matter what it is, as long as it's automated, it's fine. If you can't automate it, that's a problem. And I know from my own experiences that when I wrote a bunch of tests and they weren't automatable in the sense that if I just hit Control-RA, which is the shortcut in Visual Studio, and my test didn't run and succeed, or they didn't run, or they failed because of something had to be done or set up before I could run the test, that was something that I used to really hate. Minimal is kind of talking back to the delta coverage bullet earlier. In the same way, what it means is that you need to be cautious of the fact that you don't want to write too many tests. You only want to write as many as are required. If you are satisfying all of the functional requirements and scenarios of the system you're building, then that's all you need to write. There's no need to write tests above and beyond that requirement. And if you've got gold plating in your system, maybe you got some class that can do 10 things more than the actual system requires, then maybe you need to remove that. So the idea is not to build a system that can do more than it's required to do. You should be building the system to the extent that it is required to do, so that you can ensure that is exactly what you require it to do, and so you can test against it. Tests should be maintainable. This reminds me of my when I first started unit testing, and I wasn't really sold on this idea. I mean, I used to do testing. Of course, you can't build software and not test it. I used to call them test harnesses. They were essentially a bunch of console applications that were part of source control and all that, but they were automated by way of the fact that every complex feature or scenario was tested through these test harnesses. And so if you ran a bunch of test harnesses, your tests were automated in that sense. But the notion of unit testing, as I was first introduced to it, which was test every class, that didn't quite gel with me. And so it took me a while to be convinced of the benefits of unit testing. And of course, as soon as I started writing unit tests the way I felt comfortable, which is the approach that I've been presenting to you over the last few videos, starting with the Unit Testing Rebooted video, I started to see the value for writing unit tests in the framework that's given to you by, in this case, Visual Studio and the unit testing framework, so that you can make them automated and repeatable. But Even today, I find in organizations, people treat writing unit tests as a junior programmer job. Now, I've had managers that would come to me and say, oh, just put that person on unit testing detail for a couple of months. I think new people should be starting with unit testing, but that's not because unit tests are not valuable or they shouldn't be maintainable. They should start there probably because they get a good insight into what the area of the system that they're looking at is doing and how it's expected to behave. But I think unit tests are as important, maybe if not more important, than production code. So even though we treat production code as sacred, I think unit tests are certainly at the same level, if not more. And the unit tests therefore need to go through the same rigor, the same practices, the same best practices of best coding practices as you do in your production code. If you're designing some aspects in your unit test projects themselves in regards to, let's say, a certain set of classes, method names, parameter names, all of that, the same practices should be followed there. In Ken Beck's book, when he talks about red-green refactor really meant refactor the test methods, the unit tests, not so much the code, because that was a completely different step for him to start sort of to do the design of the code, refactor the code. But when he said red-green refactor, he was talking about refactoring the test methods themselves. So you don't let the test methods get to the point where they're unmaintainable. This is a big deal. I think unit tests should be written in a very, very maintainable, clearly understandable fashion. In fact, just to reiterate this idea, I feel very strongly that I have to put in extra effort with names, parameter names, method names, test method names, and variable names and such, because I'm trying to tell my future self or somebody else on the team or somebody that may join the team in the future, provide them with as much help as I possibly can, so that when they see the test and they see the code inside the test, there's a whole lot of information in there, not by way of comments, I don't like comments, but by way of the way you name things and the way you write your code, that helps people understand what it is your intent was. Because you're in the groove at this moment in time, tackling this one functional requirement and the various scenarios, you're in the best position to write the most helpful code, variable names, etc., method names, the scenario names, all of that, to the best extent possible to help yourself, your future self, and others on the team, and future members of the team as well, understand what you were thinking and what the requirements were as you knew them then. Maybe 5 years later, requirements have changed, but at least by looking at what you've done 5 years ago, you know exactly where you were, what state of mind you were in, and what your mindset was at that time. Code coverage. This is it's a fantastic tool. I think code coverage is really great, but it's completely misused for the most part. Code coverage should be used as a guide. If you are starting with tests in a certain project, and you write the test, and you look at the code coverage, and you say, okay, well, I missed this one, branch of code over here, and you have to think about, like, why did I miss it? Did I not get a certain scenario or functional scenario in place? Or is that conditional branch probably not even required? So you have to make that choice. But you can use code coverage for those kinds of things. You might have missed a certain class. Oh yeah, I didn't. This one class is not in play and it's not been tested. Either you miss a scenario, or you need to write a class test or a class integration test to make sure that class is completely tested. And unfortunately, managers and other organizations in general like the statistics, and they base all of their sort of performance metrics based on statistics, and so this is a good number to get, and then they drive you to high code coverage values. The other downside to going towards say a number. Let's say you decide amongst your team that we need at least 80% code coverage. Well, then everyone gets to 80%. And whether you covered the functional scenarios that are required to be covered or not is irrelevant, because you've got to 80%. And it kind of acts as a marker or a milestone for people to achieve. So in some cases, if the milestones are attainable, then people stop right there. In other cases, if they're not attainable, let's say like 100% code coverage, then people are doing everything they can to get there. And you find that to get to that 100% code coverage, you're writing lots of tests that are sort of irrelevant to the business, but you're trying to get to that number. The other side of it is that 100% code coverage doesn't imply that you have no bugs in the system. You only have the 100% code coverage only indicates that you have coverage of the code you've written. But there's, of course, that doesn't say that you missed or not missed certain functional scenarios, or that your understanding of the business requirements themselves are a bit warped, and so you've got a bug in the implementation, and your tests are not telling you that because that's your understanding. So how could you possibly know you introduced a bug? You can always trust low code coverage levels. If you've written a certain amount of code and you've got now unit tests for that, and you got a low code coverage, you can certainly trust the fact that you got low code coverage. It doesn't say anything about where you stand, but certainly low code coverage is telling you you got low code coverage, which means you have either missed a certain few scenarios or you've got some gold plating in your system. Either ways. So if you have a high code coverage, you can't quite trust the high numbers, but you can only trust the low numbers. Test-induced damage. This is probably my biggest pet peeve with unit testing, TDD and such. Something that I still see is very prominent in the software field, and was one of the reasons that I was not happy about doing unit testing, at least the way I was introduced to it, which was testing every class no matter what, testing every class in isolation. So the first bullet point that says designing for testability. Now it seems innocent, designing for testability. I think that's the problem. I think designing something for testability itself is the problem. And a lot of people are driven by this. If I do it like this, I can't test something. I'm not sure that I want to design a system to be testable. I want to design a system that works for the business at hand, for the job it's intended to do. I do believe that if you design your system well, it will be testable. But I don't start off, or I don't ever think about the testing aspect while I'm doing the design. That's not to say sometimes you trip up and introduce some bad design. Of course, we're all humans, so we do make mistakes. But the focus should be on designing a system well, doing a really good job of doing the design of the system well. And if you have designed your system well, then it should be testable. Conversely, just because a system is testable doesn't mean it's designed well. And I've seen plenty of this stuff myself. I'm probably guilty of doing it in my formative days of getting into just being able to test a system, designing a system and being able to test it without the unit testing aspect. But certainly going down the route of unit testing, I've done the same thing. I focus on the testability of it. So I'm designing everything around testing, and then I find I've got a great system that can be tested, but it's not designed well. And so you have to be very careful about that test-induced damage. Another pet peeve of mine, and I don't want to go down this rabbit hole here, is dependency injection. I personally believe that dependency injection is test-induced damage. Till date, I don't use dependency injection in my designs because I consider it to be a design damage. Now that doesn't mean I can't do testing. I can. I can do the same amount of testing that you can without dependency injection, that you can with dependency injection. I can do without. I can test every class in my system if that's what I wanted to do, test every class in isolation. But I don't like to design my classes so that they can be tested. Just like I don't like to design my systems so that they can be tested. I like to design my system and then I'll test it. But enough said about dependency injection. I know it's another religious thing with most people. Bool returning methods. This is one of those classic ones. In fact, let me show you a thing, a post from Martin Fowler where he talks about this. He shows this as an example here. So here's his mocks on Stubbs blog post. And he has this assertion here. Order.isFilled. Because this is a method, because this is Java. So in Java you don't have properties per se, you got methods. I can't imagine that the order class has a need in production for isFilled. Why would you want to know that? I mean, I call the fill method here, and if the fill method succeeded, that's fine. I don't have to check to see if it's filled. If it didn't succeed, I would expect it to throw an exception. So I wouldn't have a isFilled method or property here. And this, I believe, is test-induced damage. If I saw classes of mine having methods like this which are not really required in production, then that is test-induced damage. So bool returning methods. If you have a bool returning method, it should be an actual bool, such as is leap year, or some method like that truly requires to be a bool returning method. But I always suspect bool returning methods. The moment I see a bool return, I'm checking to see what is it doing and do I need it to be a bool. Now, if their methods are action, like insert customer, update customer, delete customer, these are actions or commands. They don't require return values, except for insert. Insert is one of those cases where it kind of has to do both, right? You create a new record and you have to return, let's say, the identifier for that record. That's one of the odd cases. But delete customer, update customer don't need return values. If they succeed, they're good. If they're not, they'll throw an exception. So if you find yourself returning a bool for those methods, delete customer, bool to tell you it was deleted or not, that's wrong. Similarly, if you have a bool for an update customer, an action or a command method, I would question that. And I see this a lot with bool returning methods or properties that are bool, so you can check up on it. So I think that takes care of the different kinds of test-induced damage. There's a variety of them, but these are the high-level ones that I think are most prominent. And people don't see them. They think it's normal to do that. And I've known people that'll go in and add methods and properties to production classes during their testing because they're having difficulty trying to test some aspect. Okay, this is probably one of the best things I've discovered, I guess, from Roy Osherow's book on the art of unit testing, which was the naming convention for the test methods. Now, in his book, it's a three-parter. So I don't mean the book is a three-parter. The method name is got these three parts to it, the underscores, delineating the parts. I've introduced class name as a first part just because in Visual Studio, when you look at the tests, let me show you I don't do that normally for acceptance tests, because acceptance tests are at that level where you don't care to know what the class is. You're only concerned about the actual unit of work. So you can see here that these acceptance tests don't have the class name as the sort of prefix. So the first part is the unit of work, the next part is the scenario, and so on. Let me just get back to the slides so I can show you. So the first part is the class name, and as I said, this was more for the reason that Visual Studio it's easier to see, because sometimes you might have the same scenario being tested from the acceptance level versus the class level, and you want to make sure that you can see the difference. So the first part is the class name, second part is the method name or the unit of work name, depending on what you're doing, what you feel comfortable with. Sometimes, in my case, most method names are the functional requirement, right? So it's not like the method names are different, and so the unit of work and the method name are in sync. The third part is the scenario. What is the actual scenario that you're trying to test around that functional requirement, and then your expectation of that, or the business's expectation of that in that scenario. So if I look at over here, for example, I got this one scenario, one functional requirement. There's 5 scenarios. So the first one, so the functional scenario is register member. The scenario is with existing member email. The expectation is should throw. The next scenario is with null email address, should throw. With null full name, should throw. With null password, should throw. With valid parameters, should succeed. And so, of course, there's one positive next test, all the others are negative tests, but they're all being tested. And so it's very easy to understand what is it that you're trying to test. What is it that you're doing in that test? If I look at the test method itself, you can see that I can see with null password should throw. And immediately I know exactly what the scenario is and what the expectation is. The other thing I do is when I start writing the tests, once I've defined the scenario and expectations, so in other words, once I've written the test method itself, I start with the assertion. So I'll go into the test method and if I'm not ready for the code at this point, I'll write it in comment form. How do I intend to assert on that expectation? I find that helps me think about what it is that I'm trying to test and how will I do the testing. Okay, so this is the same as or similar to your coding convention and coding, guidelines, I guess, where from a maintainability standpoint, you want to be very aware of method names, variable names, and such. And I think in unit testing, when you write your test methods, is even more important. Let me see if I can show you something here. So the scenario here is with null password should throw. So register the member with null password should throw. This is the register member method here, and this parameter here. If I would just put in a null there, I'd say, okay, well, what's the null part? Of course, now with C#, you can prefix the parameter name as well, but it doesn't help really understanding. You have to do it all, so it clutters up the code a bit, really. I prefer to make sure that I name my variables with the intent. So by looking at the variable name, I can tell the value, if you will, in this case. In these cases where it's really important. So here, it's with null email address. I got a null email address. So you can see that this parameter is the null email address, and so on. So naming of the parameters is very useful, is very helpful, and also very important. Let me show you another project. Over here, this is the one you probably saw this in the test mediator, test spies video. Not supported product. I could have very easily just put an XXX right here, and I'll be wondering, why is it XXX? Why is it not something else? Why is it not ABC? Some people actually end up writing actual names that are, and you have to wonder, like, why is that supposed to be not supported? How do I know that? So the variable name tells me it's not supported. I can make it what I need, whatever I want it to be. but the name tells me it's not supported, so I don't have to worry about. I would even go further and say something like over here, let's say the first parameter here is customer ID, right? I would do something like here, relevant customer ID, like that, so that it's not relevant, right? You have a customer ID and it doesn't really matter whether it's 1, 2 or 23. It's irrelevant. So it's very clear, and the intent is clear, that the one doesn't have a meaning to your test. And makes it simple and clear for people to understand that you're only interested in the not supported product. This is irrelevant, and so don't worry about it. What is the one here? Quantity 1. Is the quantity 1 relevant to this? It's saying the scenario is when order placed with not supported product. But if it's not supported, do we care for the quantity? So I would do the same thing. I'd do relevant quantity. Hoping I'm getting the spellings correct here. And that way I can use that here. So I know by looking at this that the other two are irrelevant. Now this may be going a bit too far, but I'm trying to get across the point that descriptive and purposeful variable names is really important. And the other part is always I use the AAA style. So whatever style you're using, begin, when, then, or whatever the other behavior driven testing styles are. Even though there's no range, I leave the range blank. So it's clear to me that I just sort of miss it. I always use the markers, so I know where something starts and where it ends, sort of thing. So there's many case scenarios where you don't have an range, then it doesn't matter. Still leave the comment there, so you know that there's the part is there. I just feel it's more useful to see tests in a consistent way rather than inconsistent manner. The next two, this slide and the next one, are actually very similar. I'll talk about the assert is true and is false as along with the assert are equals. So first off, don't coerce something that is not a bool into a bool, so that you can use the is assert is true and is false. That's the wrong thing. Unless the thing you're trying to assert on is intrinsically true or naturally bool, don't coerce it. An example is, let's say you have a count of something and you say assert is true, blah dot count equals 3. And so you coerced it now. You're saying blah dot count equals 3 is a bool expression, and you're saying is that assert that is true. Let me show you by way of code example. Okay, so let's write a new test method here. I won't bother naming the name here correctly, but so let's say we have let's say the test is all right. So I'm not going to do it for real. I'm going to just show you this. So expected quantity in stock is, let's say, 3, and when you do your act, you get actual quantity in stock. Let's say this is 3, and then you do an assert. So you say assert dot is true, expected quantity in stock equals actual quantity in stock, right? So I'm going to run this test, and this test passes, everything is good. Now what if it doesn't? What if the expected is not the same as actual? You'll see here now that the error message, sorry for this one, is the test failed, and it says assert is true failed, and you have no idea why it failed. So what are you supposed to do with that? Now an alternative is the r equals, which is what I'm actually suggesting, but I go actually further than that. So let's say r equals, and you say expected quantity in stock and actual quantity in stock. And let's say we run this test again, and you find that even here it says expected 4, actual 3. Now imagine you got thousands of tests and this one test fails. What are you supposed to expect from understand from here? You can't understand even with the numbers. You still don't know what's 4 and what's 3, right? So I suggest doing two things. One is, don't coerce things that are not bool into being a bool. Try and use assert r equals for the most part, unless the thing you're asserting on is naturally a bool, and then define a good helpful string message. So let's say was that. Okay, so now let's see what would happen when this test fails. And you see here that it gives you an actual message. So it does say expected 4, actual 3, and then it says the expected quantity of the product in stock was 4, but the actual quantity found was 3. So between the test method and scenario name and the message, it's very clear as to what went wrong and what your expectation really was. And this may seem like a lot of work, but I believe that your tests are as good as your failure messages. If your failure messages are not helpful, you might as well just not have the test in place, because when it fails, nobody understands why it's failed and what the expectation was. Of course, when you're writing this test, you're in the zone. You understand the scenario. You know exactly what is expected. That you're at the best time to write the best and most helpful message for others on the team, for yourself, your future self, and then new members on the team. So always take the time now to write useful, accurate messages, so that you understand when things fail, and somebody else who sees the test message itself. In fact, when I see this message, I can glean more information as to what the expectation of that test was. Even though it's not failed, I can just, by reading it, I can say, oh yeah, that's what's going on here. So these these messages in the asserts are useful. So always use messages, unless it's just blatantly obvious. So I already talked about both the assert r equals as well as the is true. Here's another reason for why you want to do that. If you didn't use the message, it would say something like expected register memory information, actual register memory information. You have no idea what's the difference. Like, why aren't these two equal? Right? And so it becomes very difficult to understand by looking at a message why they weren't equal. And so in your test message, you might have to go a lot further and say, well, maybe the first name was supposed to be the same, but they're not. The expected exception attribute. We talked about this in the test Spies, test Mediators video, but I'll go through the whole thing here again. I think it's important to see the actual cases here. All right, so first up, let's look at this one. So here I'm using the expected exception attribute. I'm using it in the attribute because I have this exception here, which is extremely specific. member email address not unique exception. There's only one condition under which this exception will be thrown. And so I can and probably should use the expected exception attribute in this case, because it's very, very specific. So always, or you should only use the expected exception attribute when the exception you're expecting is very, very specific. As soon as the exception becomes a little more generalized, meaning if you're using the same exception from multiple different places with slightly varying scenarios, then you should not use the expected exception attribute. So another case here is in this class. This is my member data manager class is doing a class integration test. So it's to be working against the real database. And I have this one scenario. Register member is the method name or the unit of work, with null username should throw. Right, so that's the scenario and expectation. And what I do is I create a member registration, but I null out the username, which is the scenario, with null username. And then I execute the register member method, and I'm expecting an exception here, except with SQL Server, the exceptions are always going to be an SQL exception, whether it's a store proc issue, whether it's a connection issue or a database error or internal error, it's always an SQL exception. So of course, this is like the other extreme. This exception is so generic that you just have no option but to do your testing in this fashion. But I think it's a good example nonetheless. So in this case, what I do is I catch the exception. I am expecting an SQL exception. But the problem is that SQL Server or ADU.NET, it throws an SQL exception no matter what the problem is with the database. Even if you couldn't connect to the database, it'll be an SQL exception. So here I do catch the exception, but then I go deeper into the exception, and I'm really asserting on this sort of subset of the message. I'm intentionally not trying to be very, very specific about what the actual message will be. I want a component of the message to be there. And so I'm asserting on that fact. I've got an extension method on this. It's not actually an extension method. It's another class that does the validation here. So I can give it the exception I got and the sort of the part that I expect. And this class's method does the needful, which is, let me show you that here. Simple implementation is doing an assert is true, but it's saying an exception of blah type was thrown, which is what really happened. However, the exception message was expected to contain the words blah, but the exception message was blah, right? So it just made it really simple for you to understand and see the problem. And when you do this sort of thing, when you use the try catch within your method to catch very specific exception, always put an assert.fail. So after this method, when this method is executed, you are expecting an exception. If it doesn't throw an exception, you need to fail this test. And that is critical, because if you don't, and an exception doesn't happen, your test will pass. And you think you're doing the right thing. So as soon as you have a scenario where you write the method, immediately write the fail, though you'll forget it. And then work on the implementation of the catch. In fact, what I do is when I do this, as I said, I write the method name and then I determine how I plan to do the assertion. Right away, as soon as I determine that I need to do the try catch, I'll also fill in this line here, so I know I don't forget it. Alright, so now we are kind of coming towards the end of this. Some misconceptions. Passing tests don't imply good design. Well, testable systems don't imply good design, nor do passing tests imply good design. Some people have this idea that, oh, if you can't have passing tests, then your design is not good. I'm not sure how they equate the two, but it's frequently mentioned like that, and so I thought I'd say that as a misconception. 100% code coverage doesn't imply no bugs. We've already discovered that. We talked about that, sorry. 100% code coverage, we probably also discovered it. But we talked about this. 100% code coverage doesn't imply 100% functional coverage. We even talked about that indirectly, where just because you got 100% code coverage, it doesn't necessarily mean you have implemented all of the business requirements of the system you're trying to build. Some good and bad signs. This brings us to the last slide. Change in behavior warrants tests to change. This is a good sign, because if your behavior is changed, your test must change, otherwise there's something wrong there. If they're not changing, even though you've changed your behavior, you've either missed a test or a scenario or something. So it's not a good sign if changing a behavior doesn't warrant tests to change. Refactoring warrants tests to change. That's a bad thing. We talked about this in the Unit Testing Rebooted video, where refactoring shouldn't warrant your test to change or break. So if they do, that's a bad sign. Too few tests. That basically puts you in a spot where you can't confidently change code. And that's a bad thing. That means you don't have enough tests to cover the scenarios that you're supposed to. As a result, you don't know if you can confidently change your code. Too many tests means you spend more time changing or fixing the test than you did to actually change the code or refactor the code. And that's a very bad sign. Speaks to the sort of the unit testing metaphor of, test every unit, as well as the delta coverage aspect. So if you got too much coverage in too many different ways from too many different kinds of tests, then you end up spending a lot more time changing and fixing the tests when requirements change as compared to the code itself, the production code. And that brings us to the end of this session on unit testing best practices. If you have any comments or suggestions, please let me know by putting in your comments, and I shall see if I can either answer them or accommodate some of the other suggestions that you might have with regards to videos. Thank you.